Hello students. Yesterday we have started with the IC engine systems. We have also seen the cooling system. Today we'll see the lubrication systems used in automobiles with the IC engine. So first of all, why lubrication system is required? Okay. So it reduces the friction between the moving parts. As we have seen in IC engines, we have piston and cylinder in contact with each other, which are moving with a very high speed. Due to this high speed and very less clearance between them, we need to decrease this friction. Otherwise, their life will be decreased by the wear and tear of piston and cylinder walls. So it reduces friction by creating a film between these moving parts. It forms a seal between piston rings and cylinder wall so that there will no be wear and tear to the cylinder walls, and also the life of the piston rings can be increased. So this lubrication oil, while moving in between the moving parts, it picks up particles and carbon which are formed due to the friction between them. So it does the cleaning process along with the lubrication. This lubrication oil also does the cooling as it will come in contact with the moving parts. So heat is generated due to these moving parts and also the combustion of the fuel. So that heat is also carried away along with this lubrication oil along with the cooling system. So in last lecture we have seen the separate cooling system is obviously there, but this lubrication oil will also help to do the cooling of this parts, or and it takes away some heat along with it. Lubrication also reduces the noise of the engine as metal to metal contact will be there, the noise will generate, but due to this thin film of lubrication oil this noise is also decreased. Not only noise, it absorbs shock also, whatever is there due to the moving parts. So now we'll see what are the different lubrication systems used in IC engines. So one is the mist lubrication, second one is wet sump lubrication, and third one is the dry sump lubrication. Now one by one we'll see all these three along with the diagrams. Mist lubrication system is mainly employed in two-stroke engines, that is for the small capacity engines. Okay, and where we cannot go for the wet and dry sump systems, whereas the wet and dry sump systems are used in four-stroke engines, or we can say in the large capacity engines. In between these two, wet sump is used in the small capacity engines like automobile, bikes and cars, whereas the dry sump systems are used for the large engines like stationary engines, marine engines, aircraft engines. Now, while mist lubrication system is used in two-stroke engine, because here if you see the right hand side diagram, the petrol and air mixture coming from carburetor is come inside the crankcase first, then here it get compressed, and then when piston moves downward, you can see in the left hand side diagram, through transfer port this charge petrol and air mixture is then go to the combustion chamber. So the charge initially come to the crankcase through inlet port, and then through transfer port it will go to the combustion chamber. So it is not possible or suitable to keep the lubricating oil inside the crankcase, and that's why in case of the two-stroke system or the two-stroke cycle engines, the mist lubrication system is used. So what happens in mist lubrication system is the lubricating oil is mixed with the fuel in small quantity like 3 to 6% of oil is mixed with the fuel, maybe in the air. and then this oil in the form of mist, in the form of small droplets, come inside the combustion chamber and crankcase along with this charge. And then when there is a combustion of fuel, when there is a movement of piston and cylinder, okay, so this oil droplets or the mist of oil will do the function of lubrication. So after the lubrication, when it will come in contact with the metal parts or the surfaces, later it will burn along with the fuel itself. The oil which strikes the crankcase walls lubricates the connecting rod bearings, and rest oil lubricate the piston rings and the cylinder. So here in the diagram you can see there is a reservoir, and this from the reservoir the oil is added in the flow path of the air, so it will get converted into small droplets or mist. That's why it is called as the mist lubrication system. So again the same thing is explained in two-stroke engine. The charge is compressed in the crankcase and then finally it goes to the combustion chamber. That's why we cannot keep oil in the crankcase. So it is not suitable to have a lubricating oil in the sump. So it get mixed with the fuel or the air coming to the combustion chamber in a small percentage, around 6% we can say. The fuel is vaporized and oil in the form of mist goes into the cylinder. So as we know, the carburetor does the function of mixing air and fuel, and it also vaporizes the fuel. So along with this vaporization of fuel, this oil mist, small droplets will come inside the cylinder. So this system is a very simple, low cost and does not require any oil pump or filter, because directly oil from the reservoir will get add into the fuel, and along with the fuel it will enter to the combustion chamber and it will get burned. So there is no way of recirculation, so there is no oil pump is required, there is no filter is required, because already the filtered oil is we are adding in that chamber. But due to the combustion of this lubricating oil along with the fuel, there is a exhaust smoke of burning lubricating oil will be there at the outlet. So if you have seen the two-stroke vehicles nowadays, we are not using the two-stroke vehicles or not available in market. But if you see some old bikes like Suzuki Samurai, Suzuki X100, okay, so these were the Yamaha RX100, Yamaha RX 135. So these are the two-stroke bikes. So they are a little bit more noisy than the four-stroke engines, and also if you observe, they have the heavy exhaust smoke in comparison with the four-stroke bikes or the cars. Also, it have deposit on the piston crown and exhaust port. So this deposit decrease the efficiency, and it also decrease the life of the engine. So the next method or the next system of lubrication is the wet sump lubrication. As the name is suggesting, wet sump, the bottom of the crankcase or that pan like structure, the oil is there in that pan and it is supplied for the lubrication. This oil which is gone for the lubrication is then again taken to the sump through filter and pump. That's why it is called as the wet sump, because this pan or the sump is wet, already oil is present there, and the same oil is recirculated for the lubrication and recirculated with the help of pump and filter. So the similar line diagram you can see for the wet sump lubrication. At the lower side, the sump is there in which oil is there, so it is called as wet sump. Then this oil is used for the lubrication of moving parts and of piston cylinder, bearings, and again it will come back to the sump through filter, and then finally with the help of pump. So in wet sump system, bottom of crankcase contains the oil. That's why it is called as wet sump. This is nothing but the oil reservoir during the lubrication. Oil dripping. So whatever given for the lubrication. So later it will drip. So the oil dripping from cylinders, bearings, moving parts flows back to the wet sump and recirculated again with the help of pump and filter, because it may take along with some carbon particles or some debris along with it, so we need to filter it also. So there are some types of wet sump lubrication, so one by one we'll see them. First one is the splash lubrication system, second one is splash and pressure lubrication system, and third one is the pressure fed lubrication system. So one by one we'll see this. So the first one is the splash lubrication system. So the splash lubrication system is used in light duty or the low speed engines. The lubricating oil is stored at the bottom, as already we have seen, and engine crankcase. The oil is drawn by the pump and delivered through a distributing pipe into the splash trough located under the big end of the connecting rod. So there is a splash trough is there at the bottom of big end of the crankshaft. So from where it is given, or from where it get splash. These troughs are provided with overflows, and oil in the trough is kept at constant level so that during every cycle it get splash. A splasher is provided under each connecting rod cap, which dips into the oil in the trough at every revolution of the crankshaft, and the oil is splashed all over the interior of crankcase, into the pistons and onto exposed portion of cylinder walls for the lubrication. The oil dripping from cylinder is collected in the sump, where it get cools by the air flowing around, and the cooled oil is then again recirculated with the help of pump and strainer. So here in the diagram you can see on very left hand side, so this is the troughs are there. So during the rotation of connecting rod, due to this splasher, the oil will get splashed, the move up, and it will come in contact with the cylinder walls and the bearings, and it does the lubrication. The dripping oil is collected at the lower side, lower pan or the sump of the crankcase, and the oil level inside the tub is always maintained, so that during every rotation of the crankcase this oil can easily get splashed and can lubricate all moving parts. So as oil in every cycle gets splashed due to this splasher, that's why it is called as the splash lubrication system, and it is collected in the crankcase pan or the lower sump. That's why it is a part of wet sump lubrication, and it is called as splash wet sump lubrication system. Lubricating oil is supplied under pressure to main and camshaft bearings. The same diagram here also you can see. Oil is supplied under pressure to pipes which direct a stream of oil against depots on big end of connecting rod, bearing cup, and thus the crankpin bearings are lubricated by splash of oil thrown up by the dipper. Here you can see that droplet of oil due to splashing in the diagram. Here it is also clearly visible. Some magnified diagram I have for you. So the next type of wet sump lubrication system is pressure feed lubrication system. So in this system, oil is drawn in form the sump and forced to all main bearings of the crankshaft through distributing channels instead of splashing it. A pressure relief valve will also be fitted near the delivery point of the pump, which opens when the pressure in the system attains the predetermined value. An oil hole is drilled in the crankshaft from the center of each crankpin to the center of an adjacent main journal, through which oil can pass from the main bearings to the crankpin bearings so that oil can be supplied to all parts for the lubrication. From the crankpin, it reaches piston pin bearing through a hole drilled in the connecting rod. The cylinder walls, piston, and piston rings are lubricated by oil spray from around the piston pins and the main and connecting rod bearings. So here in picture you can see the oil is supplied not only due to the splashing, some spray is there to lubricate the piston and cylinder, and for the bearings, the oil is supplied under pressure with the help of some pump. Then again, the oil is collected, dripping oil is collected in the sump, and same is recirculated through the oil filter. As here, the oil is supplied at some pressure with the help of pressure pumps. So that's why this lubrication system is called as pressure fed lubrication system. So here there is a no trough and there is a no splashings. So this is the difference between splash and pressure fed lubrication system. The basic concept is same. The oil is stored in the sump. That's why it is called as wet sump, and from where it is recirculated through the oil filter. So one more diagram, line diagram. So if it is asked in examination, you can draw the line diagram of pressure fed lubrication system. The next type of lubrication system is dry sump lubrication system. As already we have discussed, dry sump lubrication system is used for the high capacity engines or where the more lubrication is required and where wet sump lubrication system is not sufficient to provide the lubrication. So it uses an additional pump as well as a remote oil tank. As the name is dry sump, the sump or the pan below crankcase or in the crankcase the sump is dry. There is no oil stored in that sump. That's why it is called as the dry sump lubrication system. It have some remote oil tank and from where this lubrication oil is taken for the lubrication. It is used when a wet sump cannot cope up with the oil supply, means when more lubrication is required. In extreme conditions like heavy acceleration, off road driving, steep hills, and uneven surfaces, and for the large capacity engines. In dry sump lubrication system, the supply of oil is carried in an external tank, separate external tank. Oil pump draws oil from the supply tank and circulates it under pressure to various bearings of the engine for lubrication. Oil dripping from the cylinders and bearings into the sump is removed. As we have to keep the sump dry, there is no oil stored in the sump. So oil somehow is dripping in the crankcase, in the sump pan below. So that is removed with the help of scavenging pump, which in turn oil is passed through a filter and is fed back to the supply tank. Obviously, the same oil is recirculated. With the help of the scavenging pump, the oil is removed from the sump and is again taken to the tank through the filter, so that if there is any carbon particles, debris are there, that can be removed, and later it will not harm to the moving parts. Thus, oil is prevented from accumulating in the base of the engine. The capacity of scavenging pump is more than the oil pump, so that it will take care that no oil will be stored in the sump and sump will always be dry or empty. In this system, a filter with a bypass valve placed in between scavenge pump and supply tank. This filter, if get clogged, pressure relief valve opens, permitting oil to bypass filter and reaches supply tank, so that it will not stop the supply of lubricating oil. Otherwise, it may cause damage to the moving parts. Here you can see in the diagram the dry sump lubrication system. The sump below the piston cylinder arrangement, crankcase is dry. The oil is removed with the help of scavenging pump and it is sent to the supply tank. Then supply tank have the separate pump and piping, so that oil can be taken for the lubrication to the different moving parts and bearings. One more diagram you can see here for the dry sump lubrication system engine. Here for symbolically only one piston and cylinder is shown. It is same for the multi-cylinder engines also. The oil dripping in the sump is removed with the help of scavenging pump. Then it will went to the oil reservoir. Then it will then come for the lubrication through the pump and pressure regulator again on the upper side. So this is how the dry sump lubrication system works. The main difference is that here no oil is stored in the sump. We have a separate oil reservoir in case of dry sump. In case of wet sump, oil is stored itself. These are the lubrication systems used in automobiles for IC engines. So the next we'll see what are the components of lubrication system. So in all these lubrication system, there are some common components. The first one is the oil sump, where the oil is stored. Then oil pump, which takes oil from sump or reservoir tank to the lubricating components or where the lubrication is required. Pickup screen for the oil. Pressure regulator, which maintains the pressure in case of the pressure fed system or dry sump system. Oil filter to remove some debris or some carbon particles collected. Bypass valve if filter get clogged. oil galleries, deep stakes, and pressure indicators are also the important part of the lubrication system. The next we'll see what are the properties required in lubricating oil. So lubricating oil is there to reduce the friction between the moving parts. Lubricating oil also avoid overheating of components, as we have discussed. It does some amount of cooling also. It reduces the wear of components by forming a thin film between the moving parts. It reduces corrosion of metallic parts, as a thin film is formed over these metallic parts, so it avoids corrosion also. It also reduces the deposits on these metallic parts. It acts as a coolant. The lubricating oil should have capacity to operate over a good range of temperature. As we have seen, during the combustion of fuel, the temperature rises very high. So at this high temperature, the oil should be stable. It should not get dissociate, or it should not get burn at that temperature. It should not oxidize, so rusting should be avoided. Higher flashpoint and firepoint temperatures need to be there for the lubricating oil. Already in the basic thermodynamics, we have measured the flash points and fire points, the temperature at which it starts catching fire and the temperature at which it actually starts burning. We have measured this in our lab. Lubrication oil may be from animal origin, vegetable origin, mineral origin, and synthetic oils used for the lubrication. So, in lubricants from animal origin, we use tallow oil, lard oil, porpoise oil. In vegetable, we have castor oil, olive oil, or cottonseed oils. From mineral lubricants, we have solid, semi solid, and plastic. And finally, nowadays, we are using the synthetic lubricants also, because synthetic lubricants do not break down easily and do not produce coke or other deposits. Along with these lubricating oils, some additives are also used in the lubrication oil to avoid corrosion and rust. Some anti-foam agents, some detergent dispersions to improve the pour point, to improve the oiliness and film strength. So these additives are used. So, SAE, Society of Automotive Engineer, has given some numbers to lubricating oil, and as per application, some specific SAE number oils are used. So these numbers are given as per their viscosity and the temperature at which they are working. So if you have observed the oil cans which are available for the lubrication, you will find the SAE numbers written on them. For example, in case of winter, we use 5W, 10W, 20W, and for normal V's you use 20, 30, 40 number oils. So this is again separate topic, how these numbers are decided and what is the significance of this. But these numbers helps us to decide the oil according to their particular applications. So here we have completed the lubrication systems used for IC engine. Thank you.